Hi guys, welcome to another episode of Starting with Starling. In this 11th episode, let's take a look at particles. We'll basically explore two ways of creating particles using Starling Framework. The first way is to create and control each particle of the system manually. This is very similar in process to the Flash display list code we write, just that the APIs are going to be Starling specific. In the second approach, we shall explore an extension to Starling Framework in which we can create particle systems of different kind and control the overall behavior of the particles, making them look and behave more natural. To start off, let's learn and create particles manually using Starling APIs. We'll implement this and display when the hero eats a food item. For each particle, we'll use a simple image that is already part of the sprite sheet I have provided. I call this eat particle. You can find this in the sprite sheet under the name particle eat. Now to implement it, we'll go to the ingame.as and find the place where there's a collision happening between the hero and the food items. That's there in the animate items function under the bounds check condition. Here, let's call a function create eat particles and pass the item to track as the reference item where the particles need to be created. In fact, you could even just pass the x and y coordinates of the item for much more efficiency. You don't need to pass the item itself. I'll create the function now. Inside the function, let's assume the number of particles we'll create per item is around 5. Keeping that in mind, I'll declare and initialize a variable count with a value 5. Let's generate the particles through a new object type particle. So obviously we'll have to create this new class that will hold the particle image. So file, new, ActionScript class and give it a name particle and extend it from the class starling.display.sprite. I'll put this in the objects package. Now in this class, I'll create some variables that are required to animate each particle. Private var underscore speed x of type number, private var underscore speed y of type number, private var underscore spin of type number, and lastly the image that shows the particle itself, private var underscore image of type image. Inside the constructor, I'll initialize the image first. Underscore image is equal to new image. I'll get the asset from assets dot get atlas dot get texture of particle eat. This is the name we saw in the XML file. I'll align the image to the center of the sprite. Underscore image dot x is equal to underscore image dot width multiplied by 0.5. Underscore image dot y is equal to underscore image dot height multiplied by 0.5. This dot add child underscore image. The last thing to do in this class would be to create getter and setter functions for the speed and spin variables. So I'll press Ctrl 1 on each of these and choose OK. I'll do the same for the others. We are done with this class now. Let's go back to the ingame.as. Now inside the create eat particles method, I'll write a while loop. While count is greater than 0, I'll decrement the count minus minus, and create a particle. So var eat particle of type particle is equal to new particle. I'll just add it to the display list. This dot add child eat particle. Eat particle dot x is equal to item to track dot x plus math dot random multiplied by 40 minus 20. Each particle dot y is equal to item to track dot y minus math dot random multiplied by 40. This is just a random xy positioning of the particle around the item, and then I'll set the speed values. Each particle dot speed x is equal to math dot random multiplied by 2 plus 1. Each particle dot speed y is equal to math dot random multiplied by 5. I'll give it a spin value. Each particle dot spin is equal to math dot random multiplied by 15. I'll also scale each particle to a random size. So each particle dot scale x is equal to each particle dot scale y is equal to math dot random multiplied by 0.3 plus 0.3, just to avoid getting a 0. Now these are just some random values I've experimented with. Feel free to change them and see what happens. Now I have set the initial position, speed, spin value and the size of each particle. It's mostly random. Next we'll have to animate these. So I'll push every particle I create into a vector or an array. So I'll create a new vector in the beginning, private var each particles to animate of type vector that will contain the objects of type particle. And I'll initialize this in the initialize method. Each particles to animate is equal to new vector. I'll come back to the create each particles method and push the newly created particle into this vector. This denotes that a particle is created with random positioning, scaling and speed or spin values and is now ready to be animated. Each particles to animate dot push each particle. It's now time to animate the particles inside this vector. So heading back to the onGameTick function, right after the animate items function call, I'll call a new function, animate each particles, and define it. Inside this function, I'll run through a loop for the each particles to animate vector. So for var I of type uint is equal to 0, I is less than each particles to animate dot length I plus plus. I'll first identify the particle to animate. So var each particle to track of type particle is equal to each particles to animate of I. If each particle to track, just a null check, I'll reduce the size of the particle in each call by a tiny fraction. Each particle to track dot scale x minus equal to 0.03. Apply the same to scale y. So each particle to track dot scale y is equal to each particle to track dot scale x. Move it vertically based on the particle's speed y. Each particle to track dot y minus equal to each particle to track dot speed y. Reduce the vertical speed. Each particle to track dot speed y minus equal to each particle to track dot speed y multiplied by 0.2. Move it horizontally based on the particle's speed x. Each particle to track dot x plus equal to each particle to track dot speed x. Reduce the horizontal speed. Each particle to track dot speed x minus minus. Now I'll rotate the particle based on its spin force. Each particle to track dot rotation plus equal to degrees to radians, eat particle to track dot spin. Now I'll increase the spinning force. So eat particle to track dot spin multiplied by equal to 1.1. If the particle is small enough, I'll remove it. If eat particle to track dot scale y or scale x is less than or equal to 0.02, then we'll remove the particle from the vector so we can stop animating it. Eat particles to animate dot splice. I'll remove the element in the location I and I'll remove one item. We'll also remove the eat particle object from the display list. So this dot remove child eat particle to track. Then we'll set eat particle to track is equal to null. This should do. Let's run this. Now as the hero collides with the food items, you can see a small particle set getting created and then destroyed after spinning and contracting. This is basically the initial understanding of how particles are manually created and animated. Now a few points to note before we proceed. This was just one of the many different ways you could create particles manually and animate them differently for different scenarios. Even though this process works, not all the steps in this process were the best way to complete the task. We created new objects every single time and destroyed them after their use. This is not the best way to deal with the problem. There is a very popular mechanism of dealing with multiple objects on screen that are reused. One of them is called object pooling. And this is where you create a bunch of identical objects and push them off screen or hide them when you are not using them. That is, before creating and after destroying them. But once you need a particle back, you can just unhide one object from the pool of objects you created. This way, you eliminate the process of creating a display object, initializing it, adding it to the display list, etc. I have not covered this topic in this video, but if you feel the strong need for this, please do write in the comments and I'll decide to do it if I get enough requests. And for Starling specifically, there is another way of creating simple images that are identical, as in the ones that have same images to display, the ones like these. This is done using an API called quad batch. You may explore that in the Starling documentation. Now I have given you a basic introduction, logic, and an idea about handling particles. You are free to explore and improvise on this foundation, alright? The second part of this tutorial is to create awesome and almost real looking particles using an extension of Starling Framework. So the first thing to understand is that Starling Framework is open source. This opens up an opportunity for awesome developers like yourselves to write custom extensions. One such really useful and helpful extension is the particles extension. Before we begin, since these are set of class files, you will need to download them from GitHub going to the following URL. So you download it by clicking the zip button right here on the page. As usual, extract the zip file after downloading it. Once extracted, get back into Flash Builder and right click on your project in the Package Explorer. Go to the Properties and navigate to ActionScript Build Path. Under the Source Path tab, click the Add button and choose the src subfolder that resides inside the extracted folder. Click Open and choose OK. This is the same process that we followed for the green sock library and the Starling framework itself. Now after that, you can start using the APIs inside this extension. Now what particles would we create or how would it look like? This is something we can do visually. You don't need to code every bit of it. To do that, we'll use a third-party utility application called Particle Editor made for Starling framework. It's created by 1x1 Design. This is a free browser-based Flash application, so you don't need to install anything. Just visit 1x1design.com/flash/particle editor to access it from your browser. As you can see, this is a preview of how the particle system will look like once you use it in your game. So you can go ahead and customize a lot of different aspects of the particle system here. Let's start doing just that and customize a nice force field for our flying hungry hero. Please do spend more time and experiment and have fun here. Believe me, this is a great fun tool to spend your time as a designer. Now, I'll not go into each one of these parameters in detail. I kind of know what parameters to vary, so I'll just go ahead with that. You're free to experiment. First, the lifespan of the particles is going to be around 0.5. Then I leave the start size of the particle to 70 and set its variance to 0. Same with the finish size, I'll set the variance to 0. Emitter angle would be around 180 because the hero is flying towards the right side. And the angle variance will be a little, around 2 to 5. Next, I'll set the speed to something around 320. The speed variance is going to be 0 since the hero is moving at a constant speed. I'll change the color to something around blue. So for the start color, the R will be 0, the green will be 4, and the blue will be around 5. I'll set the alpha to 1. And for the finish color, I want it to be red. So the red value will be 1 and the rest, including the alpha, will be 0. Lastly, I'll fix the maximum number of particles to a value around 50. A common thing to note is that more the particle count, more the processing effort. So try and keep it to what is actually required at a minimum, avoiding maxing it out. That's it. This is pretty much what I wanted to achieve. Additionally, you can also experiment with the different emitter type. Currently we are using the gravity-based emitter. You could also try out radial emitter. Then there are different blend modes you can also set. Also, like we did in the first method, you need an image that is going to be used here as a particle. That is termed as a texture in this scenario. There is a default texture assigned, which is a circle with a softened edge. You could go to Edit Texture panel and change it to one of the listed textures or upload your own PNG image altogether. Lastly, you can export your particle to a zip file that contains the particle file. Particle file is .pex and the texture file will be .png. These are the two files we use to create particles in our game. I also have some presets that I've created for different scenarios in games. I'll let you know where you can access them at the end of this video. So you'll export this particle setting, save the zip file locally, and extract it. I'm not going to do that because I already have provided the particle files as part of the assets for Hungry Hero game. You should find it in the subfolder Media, Particles in your project. Since both the particles I use in the game use the same texture file, I just retained one PNG file. So let's use particlecoffee.pex from this folder. If you just double click and open the file in the text editor, you will notice that this is a very simple XML file. You still can fine tune the values here or manually change the particle system settings. Of course, if you know what you're changing. To use this, I'll create a new class for ease of understanding. File, New, ActionScript class, and name it as assetsparticles.as. I'll extend it from nothing and place it in the default root package. I'll delete the constructor and embed the two files. Embed source is equal to media/particles/particlecoffee.pex. I'll need to provide a MIME type. So MIME type is equal to application/octet-stream. I'll store that in public static var particle XML, that will be of type class. Embed source is equal to /media/particles/texture.png. I'll store that in public static var particle texture of type class. Go back to the ingame.as and declare a variable private var particle of type PD particle system. Now I'll navigate and find the draw game method. And here, after I create the game background, I'll initialize the particle variable by providing the XML file, which is the .pex, and the texture file, which is the .png. So particle is equal to new PD particle system, I'll pass the first variable XML of new assets particles dot particle XML. The second will be texture dot from bitmap of new assets particles dot particle texture. Also, since this is an animation, you would need to add this particle to the juggler. Without adding it, it won't just run. Starling dot juggler dot add particle. Also, we'll hide the particle object till the hero flies into the screen. So particle.x is equal to -100 and particle.y is equal to -100. I'm just setting it off screen. Also set the particle scale x to 1.2 and the particle scale y to 1.2. Then add the particle object to the display list, this dot add child of particle. Save your file now. Now a small note at this stage. If at all you get any sort of error when you save here, make sure you go back and check the version of Starling Framework and the particle extension. If you have been using Starling Framework library files since a while, you might want to update the library files to the latest. If there is an error, it is probably because your Starling library is old and the particle extension library is new. There might be some incompatibility there. So just verify both and make sure both are latest. Okay, assuming you didn't get any error, I'll proceed by starting the particle system when I need. Now in the actual game, I have used this particle only when the hero collects a coffee item. Here, since we have not written the logic for that, I'll show these particles all the time. You might want to show it only when necessary by adding the required code. So inside the launch hero function, in the beginning, just write particle.start. This is going to start the particle system and make it render as you customized it. One small thing left, the particle object should follow the hero's position. So whenever we move the hero, we'll need to move the particle object as well. So go to the onGameTick function method and in the beginning just add particle.x is equal to hero.x plus 60 and particle.y is equal to hero.y. Save and run. You see that? We are done with the particles. This works great, as expected. Now imagine the possibilities you have with such an awesome extension and a feature. As I said before, I do have simple preset preview app I created. It is live on hsharma.com. If you launch it, you will see some examples. I may add more examples in future. In the app, you can see that there is a drop-down menu in which you can select a preset and an example scene is shown. I'll choose the campfire preset. You can see the campfire particles there. Then I'll again choose the campfire smoke preset, a waterfall preset. Now this contains two particle objects. All the presets you see here are given for download right below the app. So feel free to download what I've customized for different games and scenarios. Alright, so that's it guys for this episode. I hope you guys enjoyed it. I see a lot of feedback and discussions happening around all the episodes. Please do feel free to continue the support and encouragement. Do subscribe to my tutorials, connect with me on Facebook and Twitter. And in the next episode, I'll talk about various topics like publishing Starling games to your devices, though there's nothing challenging there. I'll give you some of the multi-screen tips. I'll talk about preloading Starling games and also show you how to integrate Starling Framework with a physics engine like Box2D. Since this series is focused towards beginners, I'll do an entirely new video independently dedicated for Starling optimizations after this series. So optimizing tips and tricks will not be part of this series. If you have any specific requests you want covered in this series, please do let me know through your comments and emails. I'll try and cover as much as possible. So that's all friends. I'll see you very soon. Bye bye.